This week we'll be focusing on conducting t-tests in SPSS. So we'll focus on both the paired samples t-test and the independent samples t-test. So SPSS is open. So the first thing we need to do is create two different variables so that we can conduct our t-test. So let's say that we are interested in reaction time in the morning and in the afternoon. So we want to know if there's a difference, let's say, between times, so in the morning and the afternoon. So this will say morning and then reaction afternoon. Okay, so we've created our two variables. And let's say that we have data from 15 participants. Okay, so I'm just going to arbitrarily put some numbers here. Okay, and then we have our afternoon reaction times. Okay, so it's important to note if you're doing a paired samples t-test, so this is where we have the same participants in both groups, it is important that for each variable you have data for everyone, or that it's structured this way. So each condition is its own variable. So we have our morning reaction time and our afternoon reaction time, and you'll notice that we have data for all 15 participants. If we had some missing scores within here, it would be okay, but the important thing is that there is a variable for one group and a whole separate variable for another group. And this will be important when I show you how to do the independent samples t-test, because we don't exactly structure the data in the same way. So for paired samples, you need one whole variable for each of the groups that you want to look at. So we have our two groups. So actually conducting the test in SPSS is very, very easy. The first thing you do is just click on Analyze and then Compare Means. So if you recall, we are interested in the difference of the means of these two groups. So we want to know if the mean reaction time is different in the morning than it is in the afternoon. So if we go Analyze, Compare Means, you'll see that we have all our t-test options right here. And since we're looking at a paired samples t-test, so the same people, we are going to click on this option. So you can actually run a whole bunch of different pairs at once, but right now we only have the two variables, so there's really not much to set up. What we do is just put both of these variables in these cells here. What you'll notice is you have the option of putting them in any order you like. What's important to note is that this is not going to change the analyses. It's just going to flip the values, or the signs rather, on your t-score and your difference scores. So basically in this case, since we put it in this order, morning is x1 and afternoon is x2. If we'd flip it, this would be x1, that would be x2, but it's still going to give the same thing. So the order here doesn't matter. And then in the options, there is nothing. And then the bootstrap, of course, we can ask SPSS to generate us some confidence intervals for the mean differences. Okay, so keeping in mind again, we're looking at the difference between the reaction time in the morning and the afternoon, and it's going to be the means of both groups and whether those are different. So once this is all selected, you can click OK, and SPSS will generate your output. So you'll see here there's a few tables that come out. The first one is the one telling us that the bootstrapping has been done. And then the second one are just some descriptive statistics. So you'll notice that we have the mean and standard deviation and standard error for both variables that are in our data set. So in this case, it's both groups. So we have our morning and afternoon. So we can see here that the mean for the morning is 6.3 and the afternoon is 3.5, and we have 15 participants in both groups, keeping in mind that the same people, but we still have 15, and then the standard deviation, etc. And then we also have the confidence intervals of this mean estimate right there. So the next thing we have is the correlation table. And this is automatically generated when you run a paired samples t-test. So just to be very clear, this is not the correlation between the actual category or group membership and the dependent variable. It's actually just the correlation between the two dependent variables, or sorry, the two categories of the dependent variable. So what they've done is they've run a correlation between reaction time in the morning and reaction time in the afternoon, and this is the outcome and significance of this correlation. So in terms of whether or not this is applicable to your t-test, it really depends on the question that you're asking, but in most cases this table is not important because we're not really interested in whether the two conditions are related. We're interested in whether they have different means. Okay, so if you recall, when we're looking at correlations, we're looking at the relationship between pairs of scores, whereas in t-tests, we're just interested in group averages, group means rather, and whether they are different. Sorry. Okay, so this table here is actually our major results table. So what we have is the mean here, and what this actually is the value for the difference score. So if you recall when you're calculating this by hand, you had to subtract all the scores from one variable from the other, and then take the average for that difference score. So that's it right here. And then you could have calculated the standard deviation as well, and that's there. So then SPSS automatically generates some confidence intervals for the estimate of this mean difference, and we also asked it to bootstrap them as well. So basically the difference is these are the ones done through more traditional methods, and then this is the one we requested through bootstrap sampling. And essentially it's giving us an estimate of what we think this would be, or the range this would fall within in 95% of the cases. So anyway, the real, I guess, meat and potatoes of the analysis is right here. So we have the t-test, the degrees of freedom, and the significance. So as you can see here, we have a t of 12.58, and for 14 degrees of freedom, this result would be very unlikely, as we can see here, since the p is much smaller than 0.05. So this would be the result we would want to note. And then we would also, since we're looking at mean differences, we would want to actually look at the values and standard deviations of these means. So as we can see, looking at these means, the reaction time in the morning with 6.3 is much slower, or bigger rather, than the reaction time in the afternoon with 3.5. So that is the important stuff. So the mean and standard deviation here and here, as well as the test statistic, the degrees of freedom, and the significance. Okay, so that's how you run a paired sample t-test in SPSS. And now let's set it up to run a independent sample t-test. So as I mentioned before, if you're running a paired samples t-test, each condition should be its own variable. When we're running a independent sample t-test, we need to divide our participants into groups. And the way SPSS reads this information is actually by creating a grouping variable. So let's create another variable here, and we'll call this one gender. And we will say that for our gender, you can have either, there's ones or twos. So you can be a boy or a girl. So I'll just randomly assign ones and twos to the data set. So what we can see here is that we now have 15 participants with reaction time in the morning, 15 participants with reaction time in the afternoon, and then we have our gender variable where we have data for all 15 participants, except now we've coded them into groups. And this is the kind of variable SPSS needs in order to run a independent samples t-test, because it's going to group the results, it's going to compare the results of a categorical variable like this. So let's say this time, instead of looking at whether there's a difference between the reaction time in the morning and the reaction time in the afternoon, let's say this time we want to know for the reaction time in the afternoon if there's a difference between how men and women performed. So we have this variable here is our dependent variable, and then our independent variable is actually the category. Okay, so the gender variable in this case. So to conduct the analysis, again, we would go to Analyze, Compare Means, and this time we would click Independent Samples t-test. So this time we have two choices. We have to put our test variables in, so this is our dependent variable, and then we also have to indicate which variable is our independent variable. So in this case, the grouping variable is going to be our gender variable, and if you click here, you have two different choices. Okay, so you can either use the values that you've assigned within the variable to identify the groups, or you can actually use a cut point, and I'll show you in a second I'll show you in a separate example how to do that. But for now, we just need to identify which groups we're going to be looking at, and since we used 1s and 2s in the data set, we would want to use 1 and 2 right here. We click continue, and you notice now the groups have been defined because the question marks have been replaced with these values. And then we need to identify our dependent variable. So in this case, we'll take reaction time for the afternoon, put it right here. And then options, nothing to select here, and the bootstrapping should still be selected from before, and it is. So we're ready to run. We click OK, and our output is created. So again, it's taking a little longer because of the bootstrapping, and it's not happy. Okay. I'm not sure why that would be. Okay, must have something to do with how I just split the data, because I made it up. Okay. Probably to do with the fact that it's not significant and just random. Okay, so for now, just ignore the fact here. Yeah, so it has a 0 in both. Because there's no standard deviation. I see. Okay, sorry, I've run into something I'm not too familiar with. Okay, in this example then, let's just undo the bootstrapping. Okay, so I'll just take this off. And okay, there we go. Okay, so when you run a t-test without bootstrapping, you only have the two tables. It doesn't have all the bootstrapping tables. And so our first one, again, like in the paired samples t-test, has the first table is just a general descriptive statistics table. So we can see here that we have the information for reaction time, but it is split by gender. So we have the information for group 1 and the information from group 2. So if you look here, group 1 has a mean of 3.5000 and group 2 has a mean of 3.5714. So essentially what our test is doing is determining whether this difference here is attributable to error or if it would be unexpected given that the null hypothesis is true. And the results of that test are actually in this next table. However, before we can interpret the results of the t-test, we need to look at Levene's test for equality of variances. So if you recall, Levene's test is looking for homogeneity of variances in both groups. So essentially that means that we want reaction time to have about the same amount of variance for females, let's say, as it does for males. We wouldn't want there to be a lot of variance in the female scores and almost no variance in the male scores. And this test here actually tests for specifically that. So Levene's test does this again through a F ratio. So again, they're looking at variance that is explained over variance that is not explained. And in this case, we're looking at the difference between the two groups. So in this case, though, we're looking for a non-significant result. So if it's bigger than 0.05, like we have here, it means that we can assume that the variances are equal in both groups and that we don't have a problem. If, however, this were to be significant, it means that we have significant heterogeneity of variance. Okay, so it means that we have a problem and the variances are not equal in both groups and that we need to make a correction to our t-statistic and our degrees of freedom. So luckily, SPSS automatically generates that for you. So you can look at this value here, and if in the case you have something that's smaller than 0.05, instead of interpreting this row here, you would interpret this row here. And if you notice there, it identifies each row by saying this is where we have equal variances, so this is where we have homogeneity of variance, and this is where we do not. So this is where we have heterogeneity of variance. And then if you look here, we have a t-value of negative 0.145, and we have 13 degrees of freedom. So if you recall, it's the number of participants minus 1 for each group, so minus 2 overall, so it gives us 13. And we notice here that the significance value is nowhere near 0.05. So what this means is that this difference here is very small, and any differences we're observing are not unlikely. And in fact, there's an 88.7% chance that we would obtain this amount of variation between the two samples. And the actual difference between the two is 0.07, so it is quite small. And as you can see here, the confidence intervals do cross zero. So again, we wouldn't be able to have significant results even if we wanted to. Okay, I'm going to try to make a slightly better example here where I know it'll be significant. So let's say instead I'm going to sort reaction time. And now let's say I'm also going to show you at the same time how to use that cutoff value. So if you wanted to, instead of assigning groups, just use a median split or another value to divide your group into two. It's also an option. So let's say instead now we have a variable called age. And we want to know if, let's say, younger people tend to have an issue with better reaction time compared to older people, let's say. So we have 18-year-olds, and then, I don't know, and then everyone else is, let's say, 30. Okay, so we have 18 through 49-year-olds on age, and we want to know if older people versus younger people have a difference in their reaction time. So again, we'll focus on reaction time for the afternoon and not the morning. So this time, instead of splitting by gender, so either male or female, we can actually use a cutoff point, and SPSS will automatically create two groups based on that. So if we go to Analyze, Compare Means, Independent Samples t-test, this time we'll get rid of gender here and we'll replace it with age. And if we click, we don't want to use the groups, we want to use a cut point. So let's say that 21, so it's in between the two age groups, will be our cut point. So we can leave everything else as it was and click OK. And this time, SPSS has created our two groups, so we have values that are bigger than 21 and smaller than 21. So we notice we have 8 people in the bigger than group, 7 in the smaller, and we have a mean of 425 in the older group and 271 in the smaller group, and we have the same information, standard deviation, etc. So again, before we can look at the results of our t-test, we do need to look at the Levene test. And just like last time, we have a significance value of 0.777. So this is nowhere near 0.05. So we can assume that we have no issues with homogeneity of variance and that our group's variances are equal. So we will interpret this first line here. So as we can see, we have a t-value of 625 or 6.25 and 13 degrees of freedom. And the critical value for 13 degrees of freedom is much smaller than 6.25 since we have a very small probability here. So what this means is that the mean difference observed here would be very unlikely, and we can conclude that there is a significant result. So again, we have the rest of the descriptive statistics. So this is the actual value of the two mean differences, standard error of that difference, and then the confidence intervals. And you'll notice now we have significant result and that the confidence intervals do not cross zero. So the conclusion you would want to make here is you know that there's a significant difference. So just by looking at this, the results suggest that the older people have a slower reaction time or a bigger reaction time than the younger people. So that is how you conduct your independent and paired samples t-tests in SPSS. I hope that was useful, and that's it. Thank you.